I've recently posted a short video looking like this. Now it's time to expand on that. It shows a very short assembly program dumping a memory cell at a given address to the screen in binary and hex format. This is all it does, in an endless loop. How is it useful is the point of this video. But first, let's get the distraction out of the way. You are surely wondering what this blurb of pixels flashing below is. It's just a simple liveness indicator, showing that the program is actually working, didn't hang or blow up in any other way. After displaying the memory cell value in one row of text, the program increments a memory cell value in the next row. This character cell is simply showing A, B, C, D, E, and so on, but it happens so fast that even the graphics chip cannot catch up, and the character is changing mid-row. Let's focus on the top row. What's the use of a program that just shows a memory cell value over and over again without changing it? In an 8-bit machine like X65, all the processor can access is the memory. Every hardware device we want to talk to needs to be mapped into this memory. There are special memory addresses that if the CPU actually, read from or write to, the machine hardware redirects to external devices. This program is reading a register of an interrupt controller. The interrupt controller is a device allowing us to check which actual hardware devices are signaling an interrupt. Here we see that the device number 1 has an active interrupt. Interrupts are active low. X65 has 8 interrupt sources. The first 3 are internal to the machine components and 5 are externally driven. Lines 4, 5, 6 and 7 are connected to the expansion port for external devices to use. Let's connect to the expansion port with a simple breakout board. As you can see, we have 4 of the simplest possible devices. Just 4 10 kΩ resistors connected to 4 external devices interrupt lines on the expansion port. These are all connected to the 5V rail, so we see only once in the high nibble of the register value. But if we move one of the resistor legs to the ground rail, the corresponding bit changes to 0. Similarly for the other resistors on the rest of the interrupt lines. Memory mapping is the simplest way of accessing external devices. No special instructions or protocols are needed. This test validated that both the interrupt controller hardware and firmware implementation are working, and that the expansion port interrupt line connections are functional. Hope you enjoyed the video. Like, subscribe, comment,